Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 17 of 20. You have a massive codebase built entirely on standard Python data classes, and you realize you desperately need runtime validation. You might think you have to rewrite everything to inherit from a base model. You do not. Today we are looking at standard data classes versus Pydantic data classes. Python's standard library provides a data class decorator that is excellent for reducing boilerplate. It writes the initialization, representation, and equality methods for you. However, it trusts your inputs blindly. If you declare an age attribute as an integer and pass it a string, the standard data class simply accepts the string. It provides type hints for static analysis, but offers zero runtime safety. Pydantic solves this with its own data class decorator. It is designed specifically as a drop-in replacement for the standard library version. You keep your exact same class structure. You do not add any base classes. You merely change your import statement to pull the decorator from the Pydantic.dataclasses module instead of the standard library. Consider that legacy codebase built on standard data classes. You find a data class handling a configuration object. You swap the standard decorator for the Pydantic decorator. Instantly, whenever your application creates that configuration object, Pydantic intercepts the initialization. It reads your existing type hints and enforces them. If an invalid type is passed, Pydantic attempts to coerce it. If coercion fails, it immediately throws a validation error. You gain strict, type-checked assignments with zero structural changes to your inheritance tree. Here's the key insight. If both options give you validation, you must understand the difference between a Pydantic data class and a standard base model. They handle the underlying data differently. A base model is fundamentally built around dictionary parsing and provides a wide range of built-in methods for exporting data. A Pydantic data class remains a standard class at its core, keeping its traditional memory footprint and behavior. Because it remains a standard class, the way Pydantic applies validation changes. When you instantiate a Pydantic data class, the arguments are copied. The data passes through Pydantic's core validation engine, which parses and constructs new objects to match your type hints. It does not just reference the original mutable inputs you provided. If you pass a list into a Pydantic data class, the validator processes it, validates the internal elements, and assigns a completely new list to the instance. The original input list and the attribute on your data class are no longer the same object in memory. This copying behavior ensures your data strictly adheres to the schema without mutating the original input variables. The core utility of the Pydantic data class is bridging the gap between standard Python paradigms and rigorous validation. If you need a clean migration path for legacy code that already uses standard data classes, simply swap the decorator to gain instant type safety while preserving all your existing class semantics. If you enjoy the podcast and want to help support the show, you can search for DevStoriesEU on Patreon. That is all for this one. Thanks for listening, and keep building.